Hey, good morning, everybody, and welcome to session B. We're improving restoration, programmatic, and research approaches. I am Rebecca Brown, and I'm the Land Development and Cover Implementation Strategy Lead for the Habitat Cell, and I'm on the DNR side of the team. And I'm your moderator for this session. So the 6 projects in this session all focus on nearshore restoration. The health of the nearshore affects everything from sediment transport to salmon to marine vegetation. And these projects address needs identified in the marine vegetation, floodplains and estuaries, and shoreline armoring implementation strategies. Continuing to research and refine best practices will help practitioners improve and restore these nearshore habitats across the Puget Sound and beyond. All right, so we've got a series of presentations, 3 5-minute quick presentations. We're going to start with Jason Morgan, who's going to talk about a project from the Northwest Straits Foundation. So Jason, please.
Okay, thank you. It's a lightning talk, so I'm going to jump right into it. So the way we got here, which I know at least one of the organizations is going to talk today, was through this funding opportunity, investment priority D, restoration effectiveness of soft shore alternatives. So soft shore, alternatives to hard armoring to protecting shorelines for both public and private properties. Jason Toft mentioned, in the panel earlier about this like long-term restoration monitoring project he's been working on. Our organization is one of the lead partners on that with him. And something we haven't looked at yet is the soft shore techniques. We've been focusing on the removal of shoreline armor and some soft shore techniques, but that's been particularly focused on evaluating how these soft shore techniques are being utilized, how effective they are in the long term. So the goal of this project is to develop something similar to what we've been doing with that restoration monitoring, is to basically develop a long-term study. It's got to be long-term because especially on marine shorelines, these things take time to settle out. And we're also looking at changes at these shorelines, particularly with sea level rise and climate adaptation. So it's nothing we can look at in a year or two. We want to develop a long-term monitoring program that can be implemented over time and continue to pump data into it over the years to come out with outcomes. And so for this initial phase, what we're working to do is develop a set of protocols. We're looking at developing 3 protocols. We don't necessarily need to be limited to that, but it's kind of funding and timing dependent at this point, so that can certainly grow down the road. But develop 3 protocols that'll help inform this. We're looking at identifying 10 sites to start out and collect baseline data in this first round of funding. We're partnering. So to do all this, we put together an advisory team comprised of most all of the shore-friendly programs throughout the region and folks from DFW and Ecology. And so part of that is working with the shore-friendly organizations to develop a communications plan to help them with their work and how our data can help them with their work, disseminate the findings, and help inform the work they're doing on their outreach to landowners. And lastly, develop a framework. So all this data that we're pumping in, how can this data be used down the road? So this is kind of our timeline of what we're doing. I mentioned we formed an advisory team. Right now we're working on a QAP. We thought we could do the site selection and protocol development first, but then we found out we need to do a QAP first. And most of that is because part of the protocol development involves some data analysis. So now, as QAPs do, they kind of got us in a holding pattern while we're working through that process, but we'll get through it. So we're working through that. Very soon, we'll be doing our site selection and protocol development. And then, as Toft mentioned earlier as well, there's a shoreline monitoring database. If you haven't seen it before, it's worth going on and looking at. But it houses all the protocols that are currently used in shoreline restoration monitoring, and it also has a database and visuals where you can go in and it's a public access database, so you all can access this data. And so these protocols and database features will be added to the shoreline monitoring database. Then after that, we get to go have fun, get out in the field. Looking forward to that, and then we'll be working on that communications plan framework document. And as I think everybody who has a HSIL grant, we're required to do presentations. So the site selection process, as I mentioned, we're looking at approximately 10 sites. Looks like we might actually have a little bit more this season. We're looking at both public and private properties for these. We're looking at different types of shore types, trying to have an equal representation of shore types, but obviously we're a bit limited with those 10 sites. So we're kind of sorting out that process a bit. And then we are looking for a mix of completed and already restored sites. And the good thing is we had through that shoreline restoration monitoring program, we have sites that have some long-term data sets. Though these protocols can be a little bit different, they can certainly help feed into this information because there's stuff that we've already been collecting that'll plug into some of these protocols. And some of the stuff we're looking at addressing that happens in soft shore practices is beach nourishment, log placement, revegetation, drainage improvement. We're also considering removal of armoring as a soft shore technique as well. So right now, the 3 protocols we're working on is one, we're looking at an updated beach profile protocol. So we've been doing beach profiles for a long time. And we want to refine it for this study. One thing that we're looking at refining is just part of the data analysis process is seeing where we have variability and invariability in our data. So right now, for the most part, we go out to mean lower water or even lower than that. And what we know, we don't see a lot of changes down there. And it's not really addressing what we're trying to address in the upper shore. So we want to do some data analysis to determine where that variability is and what sections we should actually focus on in this study. It's also going to help us in just having the time to get out to all these sites. That combined with our restoration monitoring, like right now, we have to have daytime summer low tides to get out when we're going out that far. So if we can focus a little bit more on the upper beach, it'll give us more field days that we can actually get out there as well. And we're also going to look at, like right now, there's definitely some subjectivity when we're in our beach profile that we want to take out of for this soft shore, for example, like defining where the back shore is, defining where that back shore vegetation. We don't really have really refined protocols on how we determine where that is. So we want to take some of the subjectivity out of the stuff that we want to define in this beach profile protocol. Next.
Let me try a different mic. Okay. Yeah, there we go. Great. And this is also the mic is important also for the recording that we will have up later on our website or on YouTube or something. So our next speaker, please welcome Rachel Acker, who is presenting a project from the Washington Department of Ecology.
All right, thank you very much. Is this a good distance volume? Okay, perfect. All right, so I will be today lucky enough to present a strategic approach for advancing coastal process-based design in the Puget Sound. So focusing on phase 1, which is going to be information synthesis and analysis. I did miss an A in that coastal, so apologies on that. So like Jason mentioned, we're working in strategy 3. I'm just going to cruise through this one though. So at Department of Ecology, our section is ACRE, so Applied Coastal Resilience. Oh, Applied Coastal Research and Engineering. Whoops. So we're comprised of three separate kind of parts that we all work together. So we've got a group of engineers, we've got shoreline mapping and coastal monitoring. Specifically, that program has been going since 1997. So all 3 groups, we work together. HSIL project, doing some partnership with OSU and River Analyzer Incorporated. I think a lot of us in the room can see the difference in these 2 photos, right? As far as these top 2 photos, we're going to have hard armoring. I think we're all pretty familiar with the negative impacts from hard armoring. Loss of intertidal habitat, moving down to the photos below, they just look more natural, right? So kind of around this hard armoring, soft armoring, we've got a lot of challenges. It's why would you get soft armoring if you can get hard armoring, right? And maybe kind of recentering this around maybe more of a dynamic versus a static kind of solution. So up the top, you're static, you're not moving, you've got a hard armored wall. Or down below, like bottom left corner is off of Hidden Cove, Bainbridge Island, right? So as the water comes up, you're going to have more, the water's going to interact more with this gravel, right? So that's going to help diffuse some of this wave energy. So I think there's a lot of kind of, one of the issues is that there's a lack of confidence, right? Of few people are willing to risk the soft shore, right? There's speculation that you can only have nature-based solutions in these low energy areas. But our team, we're working out on the outer coast, right? Which has got bigger wave energy. And we're working with dynamic revetments out there. So being able to create examples is important to us to kind of help build that confidence. Jason touched on this too. Monitoring is important. Some of these projects are installed and then there isn't much long-term monitoring. So we're trying to get more monitoring data to help build the confidence around nature-based solutions. And then two kind of big ideas to come out of this like soft shore solution is you've got restoration projects and resilience projects. So over in the restoration projects, that's where you likely have hard armoring, but you may not need it. So you can take out that hard armoring and restore the area. Versus over here, you've got your resilience projects. And so for your resilience projects, you're still going to maybe have some erosion, potential for erosion. So being able to have some sort of stabilization that is less invasive than hard armoring. So with the project, I mentioned in the title, we're in phase 1. Phase 1 is composed of two main ideas. So number 1 is research in the Puget Sound region. So kind of looking at what soft shore solutions have already been implemented in the Puget Sound, if there is any monitoring data available already, what's working, what isn't. And then over here, you've got what else are we doing? Like what else is out there? So whether that's in the Great Lakes or the UK, just taking similar shorelines worldwide, like oyster reefs or, clam gardens would be an example of, we don't see too many of them in Puget Sound. Can we find other areas where we can install them? And then future project work would be phase 2, 3, and 4, with the ultimate idea of improved engineering guidance specific to the Puget Sound region. There is a bit of nature-based design guidance out there, but specific to Puget Sound, we think is really important. So end result here is, just watching this 1 minute sign. Okay. So if anyone has seen this before, this is Hosted on Ecology's website. It's our soft shore mapper. QR code's in the upper right-hand corner. But when you visit this site, what you're going to see is this photo on the left, and you've got all these orange dots. And each one of these dots represents a project that could either be, was hard armor removed? Were logs installed? Was there a setback, relocation of a structure? And so this is kind of a big, a place for all of these projects to kind of exist in the same place as a resource. So then, thank you. So then you can see these two photos on the right. In top photo taken, these are on Orcas Island. But in 1992, you've got kind of these big rocks, this riprap, that was able to be taken out. And then 8 years later in 2006, you see this restored beach, right? And so clearly they didn't need the riprap, right? So being able to have a place where all of these projects can be, I think we were talking about this in the earlier morning section, right? One place where you can kind of see a lot of different projects and help, kind of like I mentioned earlier, build the confidence of all of these projects have worked. Like we've got projects, up in the Strait of Juan de Fuca, and just being able to see that these projects are out there. So part of our goal is to update that. So I know with Shore Friendly working on the projects that they've got. Jason Toft mentioned 28 more this morning. So being able to get more projects in that database. I do want to mention I'm working on this project with Michelle Gostick, who is in the 1, 2, 3, 4 throw back there. Either of us are available if anyone's got any questions or want to talk about this more. But that's my time. So thank you very much.
Thank you, Rachel. That was great. Next, we have Catalan Plummer from the Department of Natural Resources, who will be speaking on a project we funded.
Okay, hello everyone. Thank you for being here today. I'm Catalan. I'm the sea level rise planner at the State Department of Natural Resources, and today I'm talking to you a little bit about our HSIL funded project, incorporating sea level rise resilience into DNR's aquatic leasing program. So for those of you that are not very familiar with DNR, we are the primary manager of state-owned public land throughout the state. The agency stewards 5.6 million acres of forest, range, agricultural, commercial, and aquatic lands. And we primarily manage these for ecological, social, cultural, and economic reasons, or benefits, on behalf of all Washingtonians. And so these lands are managed for multiple uses, including resource harvesting, conservation, protection, recreation, and so much more. And so of those, I'm gonna scroll down my notes here. Of those 5.6 million acres, 2.6 million are aquatic lands, both marine and freshwater. And so DNR aims to ensure protection of habitat and foster public access and water-dependent activities on these lands for current and future Washington residents. However, the agency's current land management practices do not account for sea level rise, which presents an imminent coastal threat to Washington's coast that will result in loss of land, habitat, and crucial natural and cultural resources in the coming years. And so with funding from HSIL, a team of DNR Aquatic Resources staff is using 3 to 4 case studies throughout Puget Sound that will allow us to explore how sea level rise may impact uses of and habitats on state-owned aquatic lands. These sites will represent different uses of DNR managed lands, and that can include things like boat launches, sediment caps, sewage outfalls, and a lot more. And these uses are highly vulnerable to sea level rise, as well as they also have the potential to be made more resilient via nature-based solutions. And so our team at DNR is collaborating with tribes, state agencies, local jurisdictions, and other DNR staff to understand the statewide and local context of coastal hazards and policy, nature-based solutions, mitigation of habitat loss, to formulate a cohesive response to sea level rise on DNR managed lands. So our project will result in updated management recommendations for DNR management, leadership, particularly related to how we can better steward, protect, and promote adaptation of our aquatic habitats like kelp forests and eelgrass meadows. So in pursuing sea level rise planning, our primary goal is to mitigate habitat loss on state-owned aquatic lands. As you probably know, given the audience here, Washington's aquatic lands are the foundation of a complex and interdependent ecosystem and economy. And for centuries, the people of Washington have used these aquatic lands for subsistence, for trade, for leisure. And at the same time, a vast array of interconnected species rely on these habitats. So the agency is mandated by statute to steward these lands for current and future generations. And so it's really crucial that we can understand, or that we understand how we can utilize existing tools at DNR's disposal to promote the adaptation of those habitats in order to maintain those ecological, social, cultural, and economic values that I was talking about. This project will help us understand how we can adjust our management practices to augment habitat resilience through nature-based solutions primarily, but also to fortify infrastructure so as to avoid habitat damage and loss. Okay. So this project obviously would not be possible at all without HSIL funding, especially given the challenging budget landscape that I know that we at the state are feeling for sure, and I'm sure that most of our non-state colleagues are also feeling. So our award has covered a full-time position, which is yours truly, to lead this work for the duration of the project, which completely transformed the agency's capacity for this type of coastal planning. Previously, staff at DNR had explored how to incorporate sea level rise planning and establish that foundation, but due to staff turnover and sort of shifting priorities thanks to the COVID-19 pandemic, this work is just now coming back to the forefront. So with HSIL's help, DNR is formally joining its sister agencies like Ecology, Department of Fish and Wildlife, and Department of Transportation in the coastal resilience space, and will now have a feasible chance in sort of making that case to DNR leadership that the agency really should be allocating more resources to coastal hazard planning. It's also allowed us to compensate some of our collaborators in this work, including Tulalip Tribes, Washington Sea Grant, and the University of Washington Climate Impacts Group. This is a practice that our team at DNR is really passionate about. We're really appreciative of the value collaborative governance, especially for ecosystems that belong to all of us as Washingtonians. And so being able to compensate our colleagues throughout this as they help us with this work was super key. So that's all I have for you. Please feel free to reach out to any of our great team members here with questions or comments. Thank you.
Thank you, Catalin. That was really great. And all right, so the next 3 talks are going to be a little longer, folks, and we will have some time, hopefully, after each one for a question or two. That's the goal. So we're going to start with Jody Toft. He'll be talking about a project funded through the Puget Sound Restoration Fund project.
Thank you. All right, how we doing here? Okay. I am happy to be here. I'm happy to be here with a little less skin cancer on my face, but it's not recovered yet. And so this is what crafting looks like. This is what crafting looks like. All right. So as stated, I am with Puget Sound Restoration Fund, and I'm here to talk about the work of many for a project entitled Strengthening Restoration Tools for Rebuilding Kelp Beds in Puget Sound. First and foremost, thank you, HSIL, for funding this really important work of many. This is nearly transformative funding for your project. 4 years of funding really matters, okay? Oh, where are we? There we go. So what are we talking about? We're talking about the most beautiful underwater forest builder that we have in the region, which is bull kelp. It comes by many names. Here we've got bull kelp, Nereocystis luciana, and then in Lushootseed, I'm trying to work on saying my Lushootseed words a bit better, Quaeb, okay? This is the only canopy building forest that we have in Puget Sound. We have a little bit of giant kelp that interlopes its way in the Straits, but it doesn't make its way into the main basin. It really doesn't make its way up into the San Juan Islands. And we have this floating kelp, as we call it, is in decline, okay? So use your traffic signals. We all know how to use them well. Red, bad, bad, so bad. Green, good, great. Yellow, caution. Orange, a little more caution, tending towards red. And so one of the things that and that's all I'm going to get into with this map. But one thing I'll highlight here is if these forests are in decline to the point where we've lost forest in their entirety around Bainbridge Island, we've lost forest almost in their entirety in South Puget Sound, what do we need to do to recover them? Okay, we can reduce stressors and maybe they'll come back on their own, and that is a whole nother body of really important work, but there's also an active role for having restoration tools at the ready, tested and deployable so that we can reforest these areas where we've lost our forest. So that's what we're talking about today. Project summary, words, words, words. Okay, to strengthen bull kelp restoration practices by deploying tested strategies across a broader range of restoration sites in order to identify the environmental conditions and variety of seed sources that lead to the highest rates of successful restoration. We want to be able to reforest. We want to be able to do it in lots of places, and we want it to actually work, okay? And this is, as I said, the work of many. So the project partners who are key here, we have Samish Indian Nation, Squaxin Island Tribe, the Suquamish Tribe, Department of Natural Resources, Port of Seattle, Let's Keep Going, Reef Check, Nature Conservancy, Marine Agronomics, Seattle Aquarium, and University of Wisconsin-Milwaukee, because that is where seed banking for bull kelp started. That's a fun FYI. And our objectives here, well, we learn when we do, okay? So let's outplant some seeded kelp at 4 restoration sites. Let's monitor that kelp performance, the environmental conditions around that kelp, the ecological community structure. Let's compare seed sources, data collection methods, and conditions at restored sites versus wild sites. And then let's talk about it. So what did we learn, right? And how do we share that with the broader community so that there can be restoration practitioners who are equipped to use this information in a meaningful way? Boom. All right. So project sites. We've got a few different project sites here. They're paired for restoration sites and for wild sites. So down in South Sound, we actually just have one site, which is our paired restoration and wild site at Squaxin Island. In Central Sound, we have 2 sites. Our reference site is in Elliott Bay, where there's pretty good chunk of bull kelp, and then our restoration site is at Doqueguats, or Place of Deer, by Point Jefferson near Indianola. Up in the San Juans, we have a site. Our reference site is Burroughs Lighthouse, and then our outplant site is a new one that we just put in this year. And then out in the Strait of Juan de Fuca, we have a reference site right at Freshwater Bay, and the outplant site at Morse Creek. So we'll walk through these quickly. The site in Central Sound at Jefferson Head is a site that we've been working at for several years. This is the first place that PSRF cut our teeth on bull kelp restoration. And we do that restoration in several different ways. And because I'm kind of short on time, I won't get into too much of it because I really am anxious about whether my video is going to work. That's all I want to say about that. But what we do, we go out and we collect reproductive material from the bull kelp. Those are those dark patches on the left. And then we get the spores to release from that reproductive material. And then we use those spores to create seed that we grow on spools of twine that we then use to outplant the site underwater with our dive team. So that's seed that we're outplanting in an array of anchored long lines at our Central Sound site. We're going to do that in the winter and see how it works. And we've been really, really thrilled that for the 6th year now, we've seen that forest regrow from seafloor to surface in a place where it has not been seen for 30 years. Okay. And so can we reforest in this area? By some metrics, yes, we can. Okay, but we're not going to pat ourselves on the back too much. Okay. So how does that reforested area look when we compare it to wild beds? Because if you're doing restoration, really what you're trying to restore what has been lost to what looks like what was lost. And so the way that we look at that, we look at it in a couple different ways. We're looking at we're using a seed source from North Beach, and our outplant site is there in orange, and our reference site is in blue. And then measures of success. Can we even grow that kelp to reproductive maturity? Yes. Okay. All right. You look at the kelp, it grows. It's got the brown patches on it. It's pretty yes or no. Yes. Great. Okay. Every year the kelp grows to be reproductive. That's awesome. Great. Does it mimic a wild bed in seasonality? So do we see that reproductive material come up at a similar time of year? And then does it persist for as long? And do we have as much reproductive material? Not quite. Okay. And that could be because the seed source that we're using is from North Sound, which is a different part of Puget Sound. Yes, we have all our permits, all of these things. But what we see here, the restoration site is in orange. We see that it's coming a little bit earlier. There's not quite as much reproduction, and it doesn't last for quite as long. Okay, so one of the things we'll be digging into from now until the end of our grant is understanding more about, is that a seed source issue? Is that because we're putting seed in a place where it isn't used to being? Is it an outplant technique? Is it a hatchery seed production technique? So part of this grant will help us unravel really what do we think is going on here, as well as adding more years to this story, as well as understanding more about what when we bring in some of the other sites, what do we see? Do we see this pattern hold? Does it create structure that attracts biological community? I think this is kind of a no-duh one, right? If you put structure in the marine environment, critters like structure, okay? The way in which so the short answer to this is going to be yes. But is it doing it in a similar way that it does for a wild bed? Let's see if the video will work here shortly. The way that we get at this is working through Reef Check, great program using community science divers to get out to kelp forests and take snapshots of what that community structure looks like at kelp forests throughout the region. They hit 60 sites this year. Awesome. And we're working up the data with Reef Check to be able to understand, are we seeing similar types of biodiversity across wild beds and restored beds? So TBD on that. But let's see, are you guys on your edge of your seats? I know I am. Is it going to work? Is it? Oh, this is promising. Okay, so this is at our Central Sound site. You can see this is the anchored long line that has the kelp seed unfurled on it. And this is a diver. These are a lot of fish. You've got some tubes gnats and pile perch, shiner perch. You can see the kelp growing up pretty abundant from that outplanted line. I'm just thrilled the video worked. But I think that, and then you can see some more here. You see our kelp crab having a fine time, just maybe too fine of a time. We're not going to watch the boxing videos. Sorry, guys, that's for later. But I would say, in short, where I think the numbers are going to fall out is, yes, the fish are there. And if the kelp wasn't there, albeit shiner perch or the wallpaper of Puget Sound, there's probably more fish at the outplant site than there would be in open water. Thank you. So then we get to the question of really the kicker, right? Can we just reforest it once and then have it just come back on its own? Because that's a lot more cost effective. We love the idea that we're planting out these forests, we're bringing them up to the surface, and then there are spores that are raining down from that reproductive material that are then coming to the seafloor and reactivating the next year, and that kelp forest is growing back on its own. And we do nothing and we're out of work. We've restored, right? Have we gotten to that point? Of course not. Of course not. These are new practices and this is a dynamic environment. But we are seeing signs of second generation growth. So the first generation kelp growth is what I showed you in the video, which you see there. And we've seen, imagine a group of kelp restoration practitioners and imagine how happy we were when we're like, oh, there it is, okay? And so what we've seen in 2023 and 2024 is we're seeing a few dozen of these second generation recruits. Are they from our restoration site? Probably so, because what we're seeing is we haven't seen any bull kelp forests around Bainbridge Island for so long, and we don't see there hasn't been any kelp in this area where we're doing the reforestation. So we feel like probably so. With limited time and resources, is it worth trying to chase down and tag anything genetically and then chase that down? No, we don't think it is, but we'd love if somebody else wants to pay for that and do it, no problem, okay? It's just not on our short list of things to do. Self-sustaining bed year over year, getting there maybe, hopefully so. The other items that I want to talk about here, environmental data. So what can we learn about what's going on at the seafloor and at the surface in areas where kelp exists or areas where kelp is lost? So this is our Eyes on Kelp initiative, thank you, where we have 14 instrumented sites now as shown on the map. And at each of those sites, we have instruments on the seafloor and the surface recording continuously. And so we're in the process of using those data to better understand what a kelp's eye condition looks like down at the seafloors when they start growing and then all the way up to the surface. What I'm going to show you is a violin plot here where we've got several of the sites down on the x-axis, and we've got temperature on the y-axis. And what I'm showing is daily maximum sea surface temperature by site. and seasonal bounds. So every day we have a maximum temperature we're recording on the instrument at the site. And then for a certain chunk of time, we're just, we're amassing all of those data for the site and putting them in the violin plot. These are sites where bull kelp is absent. These are sites that are dynamic and concerning. This big aggressive red line is some great work that Brooke Weigel and Friday Harbor Labs, the UW, has done, showing that there is a temperature threshold at 16 degrees Celsius, whereby young kelp have a tough time developing. I think we can see that that line intersects some of these dynamic and concerning and bull kelp absent areas in a meaningful way, okay? So temperature, not surprisingly, is probably causing a bit of trouble. A couple other things I want to note here, thank you. And so we'll dig into that more. The Squaxin Island outplant, an exciting and challenging place to work. Not because of the Squaxin Island tribe, not because of the drive down I-5, just because this is an area where we've seen a kelp bed that is trying to blink out aggressively for the past several years. So this shows a contraction of that kelp bed, the southernmost kelp bed in Puget Sound, a tribally significant kelp bed that has been contracting since 2013, showing some signs of resurgence. But then last year we had no natural kelp emerge. All we had emerge was the line that we had outplanted here. Okay, so the only kelp that was existing at Squaxin Island was this one line of outplanted kelp that did quite well. Sargassum down here, you can see, but we are hoping that more restoration this year, more studies into if there's any possibility to do a genetic rescue, dealing with maybe possibly more temperature tolerant kelp might give us a leg up here. If we can get something to work at Squaxin Island, this is the toughest nut to crack. If we can get something to work here, it should work anywhere, I would say. I'm excited we have our third outplant up on Blakely Island, off Blakely Island, in Samish traditional territory, using a slightly different technique. And this is an effort that we have underway to stop the contraction of a kelp bed. So it's a bed that's been contracting. We're planting kind of in the edges of it in hopes that that forest that we're creating, that curtain, will trap some of the seed that's falling out from the spores, and will keep that bed from contracting. And we'll see. So the last thing I would say is all this work is really, it is deeply collaborative. A lot of this work has really been driven by the leadership of the individual tribes with whom we're working. This is very place-based. So restoration in the San Juans versus Squaxin Island looks very different. And that's the importance of having this funding, is it lets us try these different techniques in different areas with different partners. And again, just as we've heard several times here, there's so much learning to be done from local projects, and we love the ability to be able to stitch local projects together in a meaningful way. So thanks to HSIL for that. Tis all. I couldn't remember where we landed.
Yeah, thank you, Jody. I always love the photos and the videos of kelp. All right. So next we've got Mitch McCluskey, and he'll be presenting on a project, San Juan Islands Conservation District project. There you go, Mitch.
Thanks. Let's get my timer up here. It's on here. No, well, actually, just use that one. How's it going, everyone? There we go. Yeah, my name is Mitch. I work with the San Juan Islands Conservation District. So I'm going to be talking to you guys today about our eelgrass restoration program. And there's a lot to cover. So this is my start out pitch to say if there's anything that you will just get a little feel on and you want to learn more about, is we'll have our technical report coming out that covers all of this stuff in much more detail than I can get in 12 minutes right now. So do not fear if I breeze through something. It will come up later. So what was the impetus for this program? Is we're seeing pretty severe declines in the San Juan Islands on the shallow edge right now. We have, I was talking to Bart this morning, like the SVMP data is showing on the deeper edges that's actually doing all right. But what the BMP data cannot capture is some of these pretty major declines that we're seeing at many sites. And it's gotten significantly worse in the last few years at our planting sites, which I will touch on in a little bit. But yeah, we're seeing these really strong declines. And of course, we don't need to get into the importance of eelgrass in this group, but really concerning for many reasons. So a huge thanks to the HSIL funding and the funders for enabling such an expansion of this work. So this work's been going on there in the San Juan Islands for a long time. The Conservation District got involved before my time, I think in 2020, and was able to do some smaller test planting items and collecting about 10,000 to 15,000 seeds, which we then go out and plant in different ways. And since then, we've been able to really expand. And the whole idea of this project is not just, okay, how do we pilot one site, but can we expand, and what does it actually take to expand this work to many sites that are declining in eelgrass as we're seeing such wide swaths. And there's a lot that goes into it, and so I'm going to kind of step you guys through here, like what that all takes. So we go out, we harvest seeds from the flowers. Now, not every meadow flowers all the time, and it flowers at different densities. And there's a little some of that. And then we bring it into the labs, and then we keep the flowers in different systems. And the seeds fall out of those flowers as they develop into these little woven baskets of screens. And we take those and we put those into a cold storage so that the seeds go dormant, and then we go plant in the spring. And then there is monitoring throughout that, which we'll get into as well. So thanks to HSIL funding, we were able to increase by 170% the amount of seeds that we got each year, which was pretty great. That sounds, there's a lot of questions that had to go into that. There was no, and kind of a theme here is we were really formalizing a lot of our protocols and things like that. And we were able to develop assessments and do some different methods testing on how to actually get in. Prior to the HSIL funding, we were only actually getting in the water via wading at low tides. We found we were able to get a lot more seeds by actually getting snorkelers in the water and actually testing efficiency of how much time it takes to go get the seeds that way, and really opened up a lot of doors. And then something I don't think oh yeah, we got our assessment framework. So then we also had to, set up surveys and assessments to go look at the flowers and actually figure out what time we need to go out and get the seeds. And they do vary in maturity rating from depth. And there's a certain window that you want to get them in so that you can kind of balance not all the seeds being gone by the time you get them, but also not bringing them too early, because if you get them too early, they won't develop. So trying to target like a certain maturity level when we go out. And something that I don't have in writing here because we're not the lead on it, but we were working with Padilla Bay National Estuary Research Reserve to start to explore what harvest impacts there are on meadows, which is something that had not been thought of much out here, or really on the East Coast where a lot of this work has been done before. And so we're able to kind of pilot that and actually enable Padilla Bay to start that work in partnership with our expanding, so that we can make sure that while we're going out to get these seeds from meadows, we're not actually harming them, testing out different methods, things like collecting every other shoot. We went with a conservative route of doing every other shoot or every third shoot at our sites to make sure that we're not just like taking all of the seeds out of these meadows, because in the San Juan Islands, these meadows were also facing pressure, the same pressures we're trying to restore, right? So we're trying to balance getting seeds out, but also not taking them all from the meadow. So the other thing is, once we get so many more shoots, we do need to expand our infrastructure. So we were able to set up 3 harvest cultivation tanks, which were these like 6-foot by 3-foot tanks, and develop the methods to be able to keep the grass alive, wet, oxygenated, and developing throughout the summer, as well as we again, as I mentioned, we partner with Padilla Bay National Research Reserve to try to get some meadow or some grass from a healthy meadow. With that, once we started bringing in that amount, we kind of realized, oh, there might be some biosecurity concerns with, there's a good amount of invasives that are at Padilla Bay that are on the islands. And so we're able to start getting UVs in and started trying to develop protocols that don't really exist for transferring eelgrass, and started kind of getting the conversation going on that. And then we moved our seeds into cold storage. Before the HSIL funding, we were a little stuck in it's actually an old morgue at FHL, which is where our operations are at, which was not getting below 5 degrees C or staying below 5 degrees, which is the maximum that we need to keep eelgrass at. We were able to set up some cold storage tanks that actually stayed cold and did a lot of pilot experiments on how to keep the grass viable, as well as the seeds from developing different diseases and whatnot. And we actually, again, kind of the trials and tribulations of this expansion is we accidentally at one point made a lot of seedlings. And so we actually developed a bit of a seedling nursery, and we're able to do some testing on how we can grow seedlings and use those seedlings for planting as well. So many roads diverging from all these different methods that we were developing as we went. Seed processing prior to this huge collection is actually all the seeds were being counted by hand. Went the goal, we were reaching for a goal of 1 million seeds. We didn't quite get there, but with that goal in mind, I decided not to count by hand, and so we were able to do different ways of counting seeds, and actually found mass to be the easiest and a pretty accurate way to be able to estimate seeds. And they do vary a bunch by meadow and depth and all of that, and so it's kind of a subsampling protocol to be able to figure that out without spending hours and hours and hours with a probe going one seed by seed. That was one of my first priorities. Yeah, so we were able to scale by order of magnitude. Part of that scaling came from, the different partnership with Padilla Bay. We did partner a lot with FHL and courses, and we're able to use the subtitle course there. They were able to use us to get their project done, and we were able to use their snorkelers to help us develop protocols that enabled us to go out besides just the 2 hours on a low tide, and actually figure out that it was more efficient. We also didn't have any really standardized protocols before we started. So there was a lot of QAP work in the beginning, as some of you might mentioned before, on actually really getting these nice and solidly done. So yeah, kind of took a little too long, but so our planting outcomes were limited. We were able to plant at test plant at 3 sites. Every site we planted at was pretty severely degraded, and actually significantly was literally, as we went out each time, I was seeing the rest of the grass fall back. And so this is kind of what I want to wrap up with is what we want to do with that. Before that, just kind of an acknowledgement of everything that HSIL, the funding, made possible. And that this isn't, I view this here as a opportunity to learn. And I think that what the project that we did with over the last few years really laid the groundwork so that now we're ready for somebody to move forward. So we were able to build out the infrastructure and those procedures that are needed for that infrastructure. We have been able to work with a ton of different people to be able to do that. I'll be publishing here kind of the manual with all those procedures will be coming out, as well as the technical report that will hopefully be able to be handed off to partners that want to continue this work. And then we've been able to formalize data assessments and everything that's kind of needed to have this package for Puget Sound on what we're going to do for future eelgrass restoration work. So if anybody is in an organization that's interested in doing this work, you should come talk to me, and I'll be able to help hand it off to you as well. And kind of wrapping up with that too is, so we will be ending our program, just so with different funding issues and that. But some of it I think is actually really interesting is that we'll be able to kind of I think, rebirthed this approach. This not growing any plants, not getting any growth, I think really stemmed from a little bit of the cart before the horse of we want to be able to plant at sites and do the monitoring and pick the sites that we're planting at with the goal of not grow eelgrass, but having the goal be what can this site do, what can actually happen at this site first, and then making the decisions about planting and whatnot. And so in the reporting and stuff I'm working on right now, working kind of through developing a monitoring protocol that can actually accommodate that more. And we're working with WDFW and WDNR, FHL, all these different partners to be able to incorporate all that knowledge. And hopefully the next person we hand this off to can take a lot of the expansion lessons we learned and pair this with a different approach that I think will be more successful at finding growth. Speaking of which, so different things that we're doing is actually Jody's team and Padilla Bay are going to be doing some cockle facilitated planting. We're gluing seeds to cockles. Excited to see that happen. And yeah, that's it. Oh, and I actually realized my thank you slide. So do it from memory. Thank you to everybody on this project. Sage Enright's been a big help. All of our partners, WDFW, WDNR, HSIL, the county, FHL, Puget Sound Restoration Fund. And then also thanks to our other funders, which is the Salmon Recovery Funding Board was a major funder for us, as well as U.S. Fish and Wildlife. Sweet, thank you. Did I go too fast? Did I go too fast? All right. Sweet.
You want to push it now? Maybe we could do one quick question now, or we can just save until the end for the group.
What?
All right. I don't know. Making it up as I go along. All right. Thank you, Mitch. That was really great. So interesting. Seeing a lot of commonalities with these projects in terms of partnerships and whatnot. Okay, so our final speaker is Mike Lemoyne, and he'll be talking about a Skagit River System Cooperative project.
Thank you. All right, this is kind of funny for me to say, being more of a freshwater guy. In my educational experience, is this is going to be a little higher elevation than our previous talks. So this is getting to the upper intertidal areas of tidal marshes. And first, I want to thank HSIL, primarily that we would probably see this project go forward independently, but it allowed us the opportunity to form a broader research team across the Woodby Basin that included Skagit, Still-Squamish, and Snohomish deltas, and work across the Tulalip tribes, the Nature Conservancy, and NOAA fisheries. So what I get to is tidal channel networks. And I started out with the idea of saying that I'm kind of a freshwater background. I went to University of Montana. There wasn't a lot of estuaries in the University of Montana area or Montana in general. But I thought a lot about stream networks and the idea that they're dendritic in nature. And the first thing I came out to estuaries and deltas was I saw these dendritic networks, these branching networks. And I got really excited because some of my research in University of Montana was around this. And then I got into learning a lot about restoration practice in estuary networks, and how it first started out as dike breaching, trying to say, like, just like what we're trying to learn, if we could do it easy and cheap, that's the best way to do restoration. Like, if we could just give it a nudge and it would take over, that would be great. But what we found out was single thread restoration projects may not be working the way that we want them to. They may not be providing the processes and the structure for the organisms that we're trying to recover for, which primarily are Chinook salmon. And one of my colleagues, Dr. Greg Hood, had done a lot of work saying, whoa, if you go to all these reference tidal channel networks, there are similarities to them. There's this range of allometric norms in which these natural reference marshes look like. And since then, restoration as a practice has been moving to adopting these allometric predictions. As I see engineers that we've worked with recently in the audience. And, but the idea is we're getting some pushback. These are expensive. Excavating additional channels is expensive. It requires excavators, time, sometimes amphibious excavators on site. And so what we're trying to do is trying to hone in from these just broad reference allometric predictions to what are fish using within these networks. And so it's talked about on the East Coast and the Gulf states about how these dendritic networks can influence fish distributions along them. But in stream systems, we've known for a very long time that confluence connections are biological hotspots in stream networks. Even English hedgerows, when there's connections of two hedgerows, there's an increase in biodiversity and use. So these branch networks actually have some structural influence on the processes and the biology of those systems. One thing is that larger systems, a larger branching system, can be more difficult. Understanding that this is higher intertidal than our seagrass examples, and it goes dry. Often these sites go dry twice a day. And so for a small Chinook salmon, which is when they really need to use these habitats, are 33 millimeters long, they're this big, it's a journey to go up into some of these bigger systems. So one question we had is, okay, there could be this hotspot structural diversity component of the network that fish could use, but also you might have some resistance of being able to get interior to these maybe larger systems. And there might be some sweet Goldilocks zone of structure with fish use. So we generally hypothesized, primarily Josh Chamberlain and I, over a few conversations, he's a NIMS scientist, that possibly these moderate-sized tidal channel networks that are heavily branched might be used more by salmon than other systems. So like I said, we've looked at fish use, and fish use is really presence, density, in a way of distribution across these networks. And we looked at them in 3 delta systems, the Skagit, Still-Squamish, and Snohomish. And these systems are a little bit unique because the seeding levels to each of the delta for Chinook salmon are different. You have 3 to 4 million outmigrants in the Skagit, about 500,000 outmigrants in the Snohomish, and then somewhere around 100,000 outmigrants in the Still-Squamish. So we have very different seeding levels in these systems. And what we did was we first went through kind of our bread and butter at Skagit River System Cooperative is we did some plan form mapping. So we looked at aerial photography and went through and mapped all these networks. And I want to show you this because this is the South Fork Skagit Delta, one of our sites. And you can see the heavily the heavy branching of some of the channels, but then you can have these smaller single thread channels down below. And overall, we have 35 networks mapped. And then the hard part, which is going to happen next week, is we assemble about 40 people to go out across TNC, NIMS, Tulalip Tribes, and SRSC, and then any volunteer we can grab or maybe kidnap to go out and we do a synoptic survey. So we try to survey within one tidal cycle so we don't get any differences in temporal seeding levels at the site. So last year, we had 414 sites across the 3 systems, and we sampled each system within that really short window. So we're trying to compress that temporal variation effect. We also have done extensive RTK GPS surveys to one thing that the plan form geometry doesn't get us is that depth, which is really important. We're also doing mapping of wood, low tide pools, and some other basically habitat structural components of interest. So today, I'm just giving you some preliminary information because we're still going to go out again this next year and sample and have a complete data set because this is just off of the 2025 survey that we did. And the first thing I want to tell you is I highlighted one set of noise that we have to control for when trying to look at these dendritic networks and fish use. One is seeding levels. So each system is its kind of own unique beast, sorry. In addition, as we're trying to evaluate the structure of confluences, so number of confluences, pools, the amount of wood, the distance to confluences of wood from the sample site, or the depth or the total channel area, channel or these kind of structural components that if you're a restoration practitioner, doing a delta restoration project, you're thinking about, you're like in those plan form designs and you're trying to pick different alternatives on these metrics. We need to account for system differences, our effort, and then local habitat factors. So the one thing that popped out when I was doing this analysis was dissolved oxygen. So something that we may be interested in here is the channel area. And here's the fish density for Chinook. I'm going to tell you right now, I just realized chum and coho are flipped. I apologize for that. I did these analyses when I had the flu. So these two are flipped. So this is coho, this is chum. And what you can see is that there's this distribution of densities, and it gets higher somewhere in these moderate channels and drops off. We can kind of see it's similar across all our species. But then there's this threshold with DO. Fish don't like really low DO. They don't like anoxic water. So I have to go in and control mathematically for this type of threshold effect within our data to tease out what the structural effect is. So, and then the other thing is, as you can see here, we have a lot of samples with 0. That's one challenge of trying to understand what ESA listed species are doing is often you get a lot of zeros. So with this, what I ended up doing was developing a negative binomial generalized mixed effects model with 0 inflation. I said system kind of has a random effect, basically saying, I understand that systems are different. So math, just make them different and portion the air structure across that. Set is the set area, the gear type, and set area is the offset. Dissolved oxygen, really addressing those absences. And then parameterize all my, put all my parameters to scale. So they're kind of all in the same scale. And if anyone wants to dig into the ARC code, here it is. But that's not what you're probably very interested in. So we'll get to this. So these are the beta measurements to the model structure across density. So the top plots here for densities. This is for DO that describes the either presence or absence. So this is when present, how does temperature, DO, depth, pool distribution, their distance to pool, distance to wood, the network complexity structure for net order, distance from or number of confluences, channel area, pool, and wood. So those are the things I looked at. And fundamentally for the different species, water depth, so deeper channels tended to be more important for salmonid species. Great. Dan Bottom has said this multiple times for Chinook. So one thing when you do this type of thing is you're like, has anyone else seen the same thing I did? And like, great. I like the fact that we're seeing similar things that Dan Bottom has reported in Oregon streams or Oregon estuaries. But what was interesting is the channel network order and the number of confluences was positive. So this idea of node junctions, these confluences, where these branches junction that we've seen in English hedgerows, that we've seen in stream systems, seem to be playing out where we have a higher probability of density, more dense fish with these systems that have more confluences, more node connections. But what was also interesting is channel area, the total channel area, so the larger channels tended to have smaller densities, less, so the catches produce less densities. This could be a case that they're spreading out more, maybe, but I think when we dig into it more, please note preliminary on all of this. I think when we dig into it more, there may be this cost of transiting these larger tidal channel networks, and they're not accessing all the locations. There's more to do. You're probably, if anyone saw this right away, you're like, Mike, you didn't measure distance. I am learning a lot about ArcGIS right now. And so I haven't been able to derive that from the planform geometry. I know how to do it, but I just haven't clicked the buttons yet. That's going to be the next thing we're going to try to do. But what I do want to say is that we're seeing some promising results that the dendritic network structure is influencing densities and likely the distributions of our salmonids, which really is honing in that we need to be thoughtful about our restoration designs in a way for fish utilization. And what we're seeing right off of this preliminary analysis is congruent with what we see in other dendritic systems across the world, influencing species and processes. So preliminary findings basically seems like there's a there. We have a lot more work to do. We definitely want another year of data. Unfortunately, if anyone remember the historic floods, we're a little worried about if there's going to be Chinook or not at our sites. But we're going to go out there and give it a good college try. And the hope is at the end of this work, we'll have a report and some design considerations for restoration practitioners, like really thinking about branching in design alternatives or thinking about distance from mouth so that you don't have a singular large network that you design for an estuary restoration project. Maybe you have a suite of moderate or smaller ones. And really also likely doubling down that excavating tidal networks is probably an important thing to do. And so I'm getting ahead of myself. I don't know if it's going to tell us that for sure, but dang it, everything we've been doing says that we should excavate. So with that, next week we do some intensive fish sampling. We got 22 folks heading out in the Skagit, and we try to get each network done in a day, and we do all the networks in a week for a system. We have some more cleanup on our planform geometry. It's hard to determine the end of a tidal channel, just in general, either from an aerial photo or from an RTK GPS. Like, it just kind of disappears, and you're like, is it here or is it here? So we went through and provided some better rules for that, and we need to kind of adjust our mapping at that. Adjust our mapping, and then, like I said, developing our other metrics to complete our analysis. So, yeah, thank you.
All right, thank you, Mike. We do have time for a couple of questions for any of our speakers. So, yes. Okay.
You had a curtain of bull kelp, it could potentially retain some spores, I guess. And I was wondering, that made me think about patch size and edge effects on patches. And is there like some minimum patch size below which you don't retain those spores and above which you do, and therefore a minimum patch size for resilience or sustainability on growth?
Yeah, so to me, that's a great question. Okay. Talking to the mic. Okay. How do we figure out what patch size is the optimal patch size to be able to retain spores and facilitate next generation kelp growth? More or less? Okay. Great question. Is there a patch size effect? Probably so, because there's, look in any place in ecology, like dendritic channels, right? Like that's sort of like a kissing cousin for patch size. Yeah, probably so. Do we know what that looks like, and how would we design our restoration around that? I don't know. That's a great modeling question, though. So we could look at things like kelp forest configuration, size, density of kelp, current condition, right? All of those things, and some other environmental factors, and sort of game that one out, and then test some hypotheses based on what we've actually seen in wild beds that exist versus some restoration sites, versus maybe some essentially some flume tests to understand how those spores stay or don't stay when we put them in a fake kelp forest. Essentially, lots of ways that one could start to chip away at that. We haven't been chipping away at that at all, but we're curious. Yeah. Mm-hmm.
Patches out there, are they in typically low energy or low current velocity kinds of areas versus areas that are more in trouble? Are they higher velocity areas? They're easy relationship like that.
in general, canopy forests like fast water, right? So giant kelp and bull kelp like quicker moving water rather than slower moving water. However, Puget Sound's super weird, and you can find kelp growing in lots of different places that don't have fast water. Squaxin Island really does not have fast water. Some of the other areas where we see kelp growing, we're kind of like, huh, that's not really fast water either. But we're not going to co-locate a nice Olympia oyster restoration project with a bull kelp project because that water is too slow. Yeah.
Hi, it's the back of the room. Question for Mike. So it's a weird year with all the flooding. And what if we all go out in the next week and we net fish, but we don't catch any fish and there's no Chinook? You know, usually we do this in part because of adaptive management and you want your numbers to signify something. But what's the answer if that happens? Because I don't know what it is either, but like, do we adjust how we sample deltas, or is it like a bigger question that we can't get at? So your broader statement to sampling deltas, a lot of you know, but we implement a long-term monitoring network of reference sites that gets that temporal effect in there. And so that's all robust to a low year like this. And in fact, it actually is really helpful because we often are a back check to WDFW smolt trap numbers. Like they said, this is the lowest estimate on record. Did you see the same thing? We're like the same. But for this project, there may be a limitation because the seeding level could influence how fish like go into these networks, how far they would go into a network. And the intent of this work was to sample at density dependent, so right after peak out migration, so that there was pressure to push the fish into these systems as much as possible. If there isn't that pressure, then there could be some complications and we'll have to think about as a research team. So that's one thing where science, natural systems, dynamic, budget processes, politics don't align. Funding cycles do not align with Chinook outmigration, never have, never will likely. And so those are things that if there was an HSIL continuing on or these programs continuing on, to think about that natural systems are dynamic. And one thing that I would say back to a conversation the workshop had was like, well, how are you dealing with climate change and how do you think about it? Well, since I started SRSC in 2018, there's been 2 extreme heat events, 2 historic flooding events, a global pandemic, and a drought. And I'm like, yeah, so everything's kind of put on its head too. Yeah.
All right, that's actually, we are done. I'm so find the person you want to talk to during lunch, which is happening now. And I've got a quick just orientation, a quick couple of things. If you ordered a special dietary accommodation, so like a gluten-free or a vegan or something, though, that food is going to be on the tables along the side of the river room, which is at the back of the big hall where we started this morning. If you didn't order a special diet, all of that food is going to be in the middle of the river room. So if you didn't order a special diet, please eat from the middle tables. Yep. And then if you're presenting in the afternoon, please arrive at your assigned room at 1:20. And our afternoon sessions will begin promptly at 1:30. So thank you, everyone. Another big round of applause for our speakers and for our attendees.